Hi there. My name is Miss Townsend, and I love math. Welcome to Math with Townsend. This video is for grade 10 academic students who are working on their summative, and it's part B of question 17. And in question 17, we are supposed to sketch and then solve each triangle. So sketch it and then solve it, meaning find all the values of the missing sides. So if you watched the first video for part A, you know that the way that I like to sketch is, first of all, I draw a really terrible sketch, meaning I just draw any old triangle, give it the proper labels, and write the values I know. And that's just to help orient myself for a proper sketch. So this is 30 centimeters, this is supposed to be 35 degrees, and this is supposed to be 56 degrees. So that's the information that I know, and now that I've oriented it properly, the green, represents my brain bubble. So now I'm going to take my ruler, my electronic ruler, and I'm going to actually try to make this triangle as reasonable as I can. And again, you're not supposed to take out some sort of protractor compass deal and actually draw a perfect version, but you are supposed to draw something that's reasonable, and therefore you can tell if your answer is reasonable. So this is what I do. And sometimes some things are easier with actual rulers, but I'll try my best here. So I drew this line here, and again, this is going to represent the line from T to S. And now I want a 56-degree angle. So a 56-degree angle, so I've drawn it at 90, so 45 would be about here. So think about where 56 would be. It would be not quite to 45 degrees, so it's about there. And I don't know how long or short this line is. No idea. So just kind of put it wherever, and we can adjust things later. So now I need to draw a line from here, and this angle here has to be 35. So think about what 35 degrees means as an angle. So 35 degrees, this would be 90. So 35 degrees would be a fairly small angle, maybe like that. Okay, so now there's my triangle. So I'm going to shorten this side. And again, this side here, whatever length I draw it at, I'm going to call it 30. So if I'm calling this 30, then presumably I'm going to have some longer sides here, and we'll see if the numbers work out. So that's my sketch. So label it. So this is R, and that was 35 degrees. This is T, and that's 56 degrees. This is S, and this side is 30 centimeters. So there's my sketch. Now we're supposed to solve the triangle. So obviously that means find the missing pieces. So one piece that's missing is this angle. What's also missing is side T, and side S is missing, and this is technically side R because it's opposite vertex R. So the easiest thing to find will be this side, because we know that a triangle, all the sides add to 180. So we can find the length of side S without too much pain, because we know that 180 minus the other two angles is the value of angle S. So angle S equals, so 180 minus the sum of 56 and 35 is 89 degrees. And this is why it's nice to have a pretty decent diagram, because I could agree that that looks like 89 degrees. So angle S is 89 degrees. So how are we going to find the length of S and T? Well, we can now use the sine law because, well, we could have used the sine law from the beginning, but we know both angle R and side R. And so therefore we can easily use the sine law. So let's go and set that up. So sine of angle R over small r is sine of S over small s, and also the sine of T over small t. So you'll notice I always put the one combination that I know. So I know both big R and little r. I put it in the middle just because it's the most important piece of the puzzle. And then, for example, I'll start by using this equation, and I will solve for my missing side length t. So what are my values? So I have sine, 56 degrees over side T equals sine 35 degrees over R, which is 30. And then I'm just going to solve for T. So let's do that. So in my calculator, make sure I'm in degree mode. I get 0.8290 over T equals 0.5736 over 30, cross multiply. So 30 times 0.8290 gives me 24.87, and 0.5736 times T, well, is just 0.5736 times T. So to isolate T, I'm going to divide by 0.5736. And what does that give me? That gives me a value for T of 42.6 centimeters. And again, the fact that we have a pretty decent diagram means that I can verify if 42.6 makes sense. And I guess that makes sense to me. And then we're going to do the same thing. So again, this one here is 42.6 centimeters. So now let's find the length of S. So now I'm going to use this equation. So let's just draw a line down the middle of the page here, because math tends to be done vertically. And let's solve for S. So again, sine R is sine 35 degrees over 30, and then sine 89 over the unknown sine S. So 0.5736 over 30 equals sine 89, which is 0.9998 over S. So cross multiply. Oops. So 30 times 0.9998 is 29.9954, and 0.5736 times S is just 0.5736x. Okay, so dividing by 0.5736, I get a value for S of 52.3 centimeters. And again, if I look back at my diagram, that makes sense that this could be 52.3 centimeters. Okay, so that's the value. Oops. That's the value. So I've solved the triangle. And again, the missing angles were, this missing angle was 89. This side is 42.6, and this is 52.3. So that was part B, and I'm going to make a separate video for part C, just so that if there's somebody who only wants to see a certain part, they don't have to go through the rest of the sections. So maybe I'll see you in the next video. Okay, see you there. See you there.